how to figure out how well you're doing in a class. So for instance, this is 12:3. Dispersion means how far apart is your data? How spread out is it? Is it really tightly packed around one number, or is it spread out over 1,000 numbers? Oh, by the way, the book has some weird calculations. Like in the first section in 12.2, I did not cover mid-range, but mid-range is such an easy thing to do. You take the biggest number, you add it to the smallest number, you divide by 2. It's not a very good measure of central tendency. This one also has a dispersion formula, and it is the biggest one minus the smallest one, and it tells you how many numbers are between the biggest one and the smallest one. Again, it's not a very good measurement of dispersion, so I usually don't teach those two because they're pretty much, well, pointless. So I'm going to concentrate on the ones that actually make sense. So let me discuss what we're really talking about here. So let's say in an English class, a teacher has 5 students. In a math class, this teacher also has the same 5 students. And they both gave a test on the same day. Maybe I should have made history. It doesn't matter. Maybe you had a paper due in English. And the tests for the English were 55, 65, 75, 85, and a 95. Those are the scores of the 5 students in English. In the math class, they scored make sure I get the numbers right. A 65, a 70, a 75, an 80, and an 85. Okay. If a teacher tells you, they hand back the test and they say, oh, the class average was an 80, does that tell you how well you did in the class compared to everybody else? No, because everybody could have scored an 80, and then everybody did exactly the same. Or there could have been a bunch of hundreds and whatnot going down to the 60s. And depending on where you were, you could usually tell if you're above average or below average, but that's all it would tell you. It wouldn't tell you if you were at the top of the class, at the bottom of the class, near the top of the class, near the median. So you have to be a little cautious of it. So, for instance, what's the average for the English test here? You don't need to do any calculation. What's the average? 75. 75. Just by looking at it, it's 75. Why? Well, because I equally spaced it going up and down. So if you added them all together and divided by 5, I guarantee you the average is equal to 75. You ready? A little new notation. The mean mathematically is written that way. It's called x bar. So, little arrow up here. This is called the mean. On the test, I do not want you writing x bar equals 5 or x bar equals 75. I need you to say mean equals 75. But you're going to see the notation x bar, and you have to understand that it represents the mean. But I don't want you writing it as your answer, part of your answer. So we're going to call this x bar English, and the average is a 75. What about the mean of the math test?
75.
It's 75 also. So these two tests have exactly the same average. The average of both tests are perfectly the same. Let's say you got an 85 in both classes. Does that mean you got the same grade in both classes, the same distinction in both classes?
No.
Why?
Because that's just the average.
I know, but if you got an 85 in these classes, did you do better in one than the other?
No.
Yes.
Yes.
Look at the grades. If you scored an 85 in English, you are number 2 in the class. If you scored an 85 in the math class, you are number
1.
I scored the highest grade in the class. So there's a distinction here. Even though the averages are exactly the same, and you received the same score on both of the tests, you actually did better on the math test than you did in the English test because you were number 1. And if there was a curve going around, you'd get an A automatically. But I don't that. We're going to talk about curving and why it's good and why it's bad. You'll see both sides of the coin. So, how do I tell the difference between an 85 in a math class if I only know the average is 75? You can't. All you can say is it's above average, but you don't know if you're number 1, number 2, or number 3. So there has to be a way of distinguishing between these. So what's the big difference between the English test and the math test? Well, the English test, the difference of the scores are all an even 10. 10, right? 75, 65, 55, 85, 95. In the math class, they're a little tighter. They're only 5 away from each other. So the dispersion on the English is bigger than the dispersion on the math. And that's why you did better on the math test, because the dispersion means it's closer to the mean. So I need to find a way of figuring out this dispersion and give it a value, give it some kind of number so I can see, compare them. If I have a dispersion of 5, that's a difference than a dispersion of 10. They're not going to be 10 and 5, by the way. They're going to be some weird, ugly number. The way we're going to do this, do you remember algebra? Did you ever do the distance formula? Between 2 points, you know, you have a graph, and you have these 2 points on the graph, and you want to know the distance between them. Do you remember the formula?
Wow.
That's slow, something silly like that.
Yeah, I was gonna say you count up when you go up.
The distance is equal to the square root of?
No. It's
Something like x squared, but it's x2 minus x1 all squared plus y2 minus y1 all squared.
Oh yeah. That's gotta find the slope and stuff.
No, that's not slope, that's distance. Slope is y2 minus y1 over x2 minus x1.
Yeah.
So, this is the distance formula. And this tells you the distance between 2 points in a plane. Now, there's an extension on the distance formula where you could have, well, this has 2 axes. You can have as many axes as you want, and that's what we're going to do with stats. And the other thing we're going to do is we're going to treat one of the values as x and the other one as x bar, the average. So we're going to do this calculation based on how far away are we from the mean, how far away from the mean. So we're going to find the average, average distance from the mean. And this actually is a neat little calculation. So the number of dimensions that we're going to have in this calculation is dependent on how many data points we start off with. Both of these start off with 5. So what we're going to do is we're going to take, make sure I write this right, the square, we're going to find the average. So it's going to be 55 minus the average, which is, 75. We're going to square it. We're going to do it totally different than what I'm doing here eventually. I just wanted to kind of get you used to what we're doing. Then we're going to take the next number, which is, we're doing English here. We're doing English. 65, and we're going to subtract it away from the mean, which is 75, and then we're going to square it. And we're going to keep doing that until we get down to the last number, which is 95, subtract it away from 75, and we're going to square it. Now that gives you all the junk underneath the radical. So guess what I have to include now? The radical. But before I do that, I want to take care of this word average. Notice I put it in quotations. It's not the type of average you're used to. We're going to average what that stuff is. So you're going to take this, and you're going to divide by, you would think 5, wouldn't you? But I'll discuss that in a second, why it's not 5. It's actually going to be 5 minus 1. 5 minus 1. And I'll talk about that in 2 seconds. You would think it would be 5. And in one calculation, it actually is 5. But this book leans a different direction, so we're going to make it 5 minus 1. And then you're going to take this whole thing and you're going to square root it. So this becomes what we're going to consider the average distance away from the mean. It gives us a number value that we can compare to other numbers.
So we need to put all that in our calculation?
No. I'm going to show you a different way of doing it.
The next number would have been 75.
75 minus 75, and then 85 minus... Yeah, you can write it out if you want. But I'm going to do it a different way, a better way than trying to write it out.
You just showed how
where it's coming from, how it's related to the distance formula. All right, now, why the 5 minus 1? There is one formula where it is 5, and then there's the other formula which is 5 minus 1. And the reason for it is this. There are two concepts in statistics. One of them is population. Like, for instance, would it be easy for the school to find the average GPA of all its students?
Yes, they have a computer.
Yeah, they have a computer. They have all your grades available to them. And they can number crunch and get the average GPA of every student that goes to this college. Would it be easy to get the average GPA of every college student in the United States?
No.
No, because they're on different computer systems and they don't talk to one another. So that would become really, really difficult. So population is not always the best way to go about things. Presidential elections are coming up. How do they find out how many people support Romney and I was about to say Gore. My God, that was years ago. Romney against Gingrich against Santorum. How do they get all those percentages? Did they talk to the entire population that's going to vote?
No.
No, they took a smaller group. They just randomly called people. Who are you going to vote for? Who are you going to vote for? Who are you going to vote for? But they're not talking to everybody. If they talk to everybody, that would be a population. But they're not talking to everybody, so that's called a sample. And that's mostly how statistics works. You don't look at everything. You pick a random sample and you study that random sample. And you say that random sample represents
Everybody.
the population. Yeah. And that's where statistics gets a little fuzzy, because if they don't do a very good sample, you're going to get data that is actually
Incorrect.
not
False.
corresponding to the population. So their trick is they take a sample and then they say, oh, that must correspond to the population. There is a whole science on how to collect data. I mean, there's a whole class on it where you learn how to make sure you're getting correct data, that you get a decent sample, that your statistics actually kind of backs up the population. So that what they'll do is take two different samples and see if they compare to one another. So this formula up here is based on a sample. And the reason to go 5 minus 1 is if you divide by a smaller number, your value actually gets a little bit bigger, so you're accounting for discrepancies between a sample and a population. If we were doing the population calculation, it would just be 5. And it would be a pure standard deviation, what's called a standard deviation. All right, so that's the reason between 5 minus 1. Now, I'd like to change this into a formula, because this is, it's messy, right? So the formula looks like this. You're adding up here these pieces, right? Since you're adding them, you're going to get a summation. The pieces you're adding together, the first number is what?
It's 5.
I know, but what's the first number represent?
5. English.
A data point, an element. How do we represent elements with symbols?
That E with the
No. In statistics.
Oh.
What letter did I use?
That's something out of 12.
You weren't here. What letter do we use for data?
N.
That's how many data. That's the cardinal number. What letter did I use last class for data? What is it? X. So, X minus X. Remember X? And what does the 75 represent here? It shows up every time. 75, 75, 75. The mean. So that would be X minus X bar. What do we do with this group? Well, you square it. And then you divide it by, well, what's 5? Now you can say the other letter. N, the cardinal number, minus 1. N minus 1. And you take the whole thing and you square root it. The square root goes over the whole thing, not just the top. Not just the top. This has a symbol associated with it. This is equal to that letter.
What's that that you just wrote?
You don't know what that is? You do not know what this symbol is? I'm having a bad time writing it. It actually looks better like that. This is the Greek letter sigma. Have you seen this letter before?
Yes.
Yes, when we were doing the Greek number system.
But you said we ain't had to learn.
No, you didn't have to memorize it. But this is called the Greek letter sigma. And in statistics, the Greek letter sigma represents standard deviation. I abbreviate it as SD, standard deviation. So if you see the letter sigma, it represents standard deviation.
Do they got symbols in like fraternities?
Oh, shoot. No, well, that's capital letters.
Phi Beta?
I'm actually wrong here. I'm sorry. I shouldn't tell you sigma. I'm sorry.
Because I thought that was
Sigma is for population. I'm sorry. It is the standard deviation, but it is for population. This one is not sigma. It is actually just S.
Oh.
It's just actually S. So sigma is for population. So if you see sigma, it represents the population standard deviation. If you see S, it represents the sample standard deviation.
So S equals that square root.
Yeah, S equals that square root thing. Now, how do I use that formula? Well, this is where it gets horrible. Y'all have calculators, I hope.
yes, we do.
Because it's going to get bad. Let me come up with a set. For example, find the standard deviation of 2, 5, 9, 17, 25, and 30. 1, 2, 3, 4, 5, 6. And is
I got a
equal to
question.
6. Yep.
The standard deviation is pointing to the sigma or to the S? Which one?
Sigma and S are both standard deviation.
Okay.
It's just that sigma relates to a population. It would be n in the bottom. S represents the sample standard deviation, and it has n minus 1 in the bottom. You're not going to use that formula directly because it gets really, well, I mean, writing it all out like this, it gets very, very tedious. Yeah, we're actually not going to use the formula until the end. So the way we're going to do this is we're going to set up a table. And in the table, you're going to start off with your x's. You're going to start off with your x's. And then you're going to build it up into your x minus x bars. And then you're going to take that answer and you're going to square it. And then you're going to take all those and add them all up. You're thinking, oh, this isn't that bad. Oh. It gets really tedious. So let's see here. This is 2. This is 5. This is 9, 17, 25, and 30. Now, before you can even do this problem, you have to find the mean. You have to find the mean because I need x bar. So, how do you find the mean of 2, 5, 9, 17, 25, and 30?
Add all of them together.
Add them all together and divide by
2.
6.
Oh, 6. Where's 6 come from? Because that's how many it is.
N equals 6. Cardinal number. So, what is 2 plus 5 plus 9 plus 17 plus 25 plus 30? 88? And you're going to divide by 6. This will give us our x bar. And this equals 14.7. Okay.
So we come over to the side.
And now you can come over here and do, well, this is going to be 2 minus 14.7. For a grand total of? What's that, negative 12.7? Negative 12.7. And then you're going to do 5 minus 14.7 for a grand total of?
Slow down, mister.
I'm just doing minuses.
Okay, minus what now?
5 minus 14.7, the mean. That number, mean. No, over here, mean. Negative 9.7. And then I'm not going to write the rest of the, this one will be 9 minus 14.7. Negative 5.7. Sad that you're using a calculator. 17 minus 14.7. 2.3. Right?
Yeah.
2.3. 25 minus 14.7. 8.3.
10.3.
Darn it. 30 minus, darn it, 14.7.
What is it? What is it, Mr. Know-It-All?
15.3.
Oh, you was right that time.
15.3. Alright. I never said I was good at calculations. Now, you have to take all these green numbers
And square.
and square them. This is where it just becomes tedious. So now be careful. If you take negative 12.7 and you square it, what kind of number do you get?
Positive.
Positive. Drop the negative. Don't type it in your calculator. Just do 12.7 and square it. Because if you type in negative 12.7 and you square it, you're going to end up with a negative answer in your calculator. And if you write it down, you're
Is
actually
it
wrong.
161.9?
So drop the negative.
Just drop the net because you're going to square it. It's automatically going to become positive. So why even write it in your calculator?
1.16.
161.29.
161.29. 9.7 squared. 83, 84.
9.1.
What is it?
94.09.
Really? Wow. 0.9. Negative, well, 5.7 squared.
32.49.
32.49. 2.3 squared. What is it? 5.29. 10.3 squared.
106.09.
106.09. And 15.3 all squared?
234.09.
234.09.
That's the answer.
Nothing is the answer yet. We're just getting it built up. Okay, what do I do with all these square terms? Well, the formula says take all these square terms and add them all up. This is a summation symbol. It means add them all up. Also, it's the letter sigma. That's just the capital letter sigma. So we're going to add these numbers up. Do you see where I have this formula sucks? Add up all these numbers. I could go to sleep during this. Yeah. Hey, who was really late today?
Well, he was the latest.
Yeah, he was, wasn't he?
63.
I was eventually going to get around to him.
Look up there.
Say it again.
633.34.
633.34. Confirmation?
Yes.
Yes. All right. So this is the sum of my x minus x squared. Now I'm going to put it into the formula. And the formula says, well, the standard deviation is equal to the square root of the summation of these square terms divided by n minus 1. All right. What is the summation of these square terms?
The
633.
The 633.34. What is my n minus 1? Well, n was equal to,
6.
so n minus 1 will equal 5. Now, don't type this in your calculator. Well, actually, yeah, you can type this whole thing into your calculator.
Wait a
Square root.
minute. Where you get your 5 from?
N is equal to 6.
Minus 1. Gotcha.
Minus 1 is 5.
Okay.
That's what happens when you don't show.
Okay.
So, in your calculator, type square root of, that's second x squared. Second x squared.
Uh-huh.
And then type in 633.34 divided by 5 and hit equals.
11.25.
So the standard deviation here is 11 point.
That ain't what y'all got.
I got 11.25.
How you do that again, man? You hit second first?
You hit second x squared. It puts the square root symbol on your screen. Second x squared. Puts a square root symbol on your screen.
Like 633.
633.34 divided by 5. 11.25.
Yeah, that's right.
Now, the original data had no decimal places. So how far do I round it? 1 decimal place. So it's 11.33. So the standard deviation of this data has a standard deviation of 11.3.
So we always round it to the nearest.
Well, it depends on your data over here. If this was 2.1, 5.3, and had 1 decimal place, then it would be 11.25.
Okay.
It would have 2 decimal places.
And the equation there's a square up here.
We squared it.
Okay, I didn't know if that was already done.
Yeah, we squared it.
Okay.
Took each one of these numbers and squared it.
So they
The
get
summation says take them all in, add them up,
Yeah, I was just wondering.
and then I put that number in that whole
So
position.
what if our answer we just round it in one place?
You have a square root.
When
There was
we
a square
determine
root.
when to round?
Put in parentheses, and then type in the numbers. What?
When we determine when to round that?
You determine how you round it by your original data. Our original data had no decimal places, you get 1. My original data had 1 decimal places, you get 2, and so forth and so on. Okay.
Okay, so square in the parentheses,
Square.
what goes in there?
Like I said though, that formula is not the best one. So I'm going to spoil you and show you the formula that most people use. And guess what the book doesn't give you? This formula. Now, what's really cool is I sat down one day and I converted this formula into the other one. It took me 40 minutes or so to convert it, to get it right. And the only reason I could do that is I knew the beginning and I knew the end. All I had to do was figure out the middle.
So I can put, don't use this formula on this?
You can. If you want to, you can use the formula, do it the book way. If you're happy with that, that's fine. I want to show you a different way of doing it, which I think is a little bit easier.
Is it easier and quicker one?
Yeah.
What we use?
Killer way.
Why would I do things slower?
I mean, I'm just saying.
My way is this. The formula becomes S equals the square root of, so you still get this big ugly square root over a fraction. The square root of the summation of x squares minus the summation of x's, and then you're going to square it, you're going to divide by how many there are, and then you're going to divide this thing by n minus 1. It didn't even record. These black markers. I'm not going to erase this. I'll write it up again. The standard deviation is equal to the square root of the summation of x squares minus the summation of x's all squared divided by n minus 1. What's really scary is I memorize these silly formulas. It doesn't even look the same as the other formula. They're totally different, which is kind of cool. But they do transform themselves into this, which is a neat little bit of algebra, but no fun for you guys. What's missing in this formula that the other one had? What variable is missing? X is up there.
Wait a minute. The means.
The means. This formula, you don't have to figure out the mean first. It's here. It's buried in this summation of x's divided by n. That's the mean. But you don't have to calculate it first. So all you have to do is follow the pattern. What do I need? Well, I need x, and I need x squared, and I need to add them both up, and I'm done. So the table becomes a little shorter. You have x on this side, and you have x squared on this side. Nothing to do with the mean whatsoever. Don't even have to calculate it out. You put your numbers down for x, which are 2, 5, 9, 17, 25, and 30. Then you take each one of those numbers and you just outright square it. You better not type 2 squared into your calculator.
25.
4,
81.
25.
I don't know 17 now.
81. 289, I think it is. But
Yeah,
289? 25 squared is 625?
Yep.
And 30 squared, of course, is 900. No, you don't have to memorize squares. Now, what you have to do with both of these columns, you have to add both of them up. So if you add up the first column, we know the sum of the first column, it's 88.
88.
It's 88, we knew that.
So if we square 88, we should get the sum of the second
No,
one.
no, my God, no. Why? Let me come over here and tell you algebra again. If I go 2 plus 4 and I square it,
I know.
it's not 2 squared plus 4 squared, it's 6 squared. All right, add up all these, it becomes your sum of your x squares. 1,924. If you forget where to put things, it works this way. The big number goes first, so it goes here. The small number goes here, and then you do your n and your n minus 1. So this becomes the square root of, big number is this 1924, small number is 88. You're going to take that number and square it. You're going to divide it by n. What's n? 6. And then you divide this whole thing by n minus 1, which is 5. Now, in your calculators, it does work out a little different. You have to do some playing around. The first calculation you want to do is the top. Just type in the entire top number and write the answer down. So 1924 minus 88, all squared, divide by 6. And I guarantee you get 633.34.
Mm-hmm.
Why? Because that's the number that we got over here.
Mm-hmm.
Right? I mean, if this formula is going to work, we better get some similar numbers. So this becomes the square root of 633.34 divided by 5. And we already know that answer. It's 11.3. Now, out of these two methods, which one works nicer?
The last one.
It's much easier. This one has all these decimals, and when you square the decimals, you get more ugly decimals. Then you have to add up all these decimals. It gets very tedious. Over here, it's whole number, add it together, plug it into the formula, and get an answer. So it's really not that hard. Agreed?
I like your way.
Of course you do. It's my way. My way's always better. Oh, I know why it's not working really well. I'm an idiot.
They charge.
Oh, I forgot my dampener. I'm surprised it's worked this well so far.
I thought that was something that he was supposed to wrap around his leg and stuff
No.
like that. I used to wonder why that was.
The system works on sound waves. So when I push here, the sound waves bounce off the tray, and it thinks it's down there when I'm writing up here. So it'll write down here when I'm up here. And it messes
I've seen that on the
yeah, it
too.
screws up every once in a while. Okay, so that's standard deviation. Your turn.
So we're going to practice.
I'm gonna let you do one. You can do it the book way or my way. I could care less, as long as you get the right answer. So, for example, find the standard deviation of 4.1, 6.3, 5.5, 7.9, 8.1, 3.0, and 1.8. Find me the standard deviation of those 7 numbers. So I'll give you a clue. N is equal to 7. The cardinal
We
number
always have that?
that you need to find that,
No, that the N equals 7.
you need to find that. How do I know N equals 7?
Because you got
Add them all
7
at
in
the
it.
bottom.
Okay.
The cardinal number. Remember cardinal number?
Yes, I remember.
So find me the standard deviation of that. I could care less if you use the book formula or my formula. See, I'm just going to do it right underneath it. What's 4.1 all squared?
16.81.
16.81. 6.3?
39.68. I mean 69.
5.5?
30.25.
32.5. 7.9.
62.41.
62.41. 8.1.
65.61.
65.61.
65.61.
And 9, of course.
3.24.
3.24. If you add up the top ones, what do you get?
36.7.
36.7. If you add up the bottom ones, you get
247.01.
0.01. Now, if you got those numbers wrong, that's where you're wrong. I mean, that's usually the most common mistake, adding them up wrong, coming up with some weird answers. The rest of it is plug it into the formula. Big number minus small number squared divided by how many?
7.
Divided by how many minus
6.
1? And you square root the whole answer. Now, calculator-wise, for those people that are calculator illiterate, it's part of the formula. If you're calculator illiterate, you type in the entire top line, including that divide by 7. And you get an answer. And you write that answer down, which is
34.60.
34.60. In your calculator, you're going to type in square root of, it gives you the first parentheses, 34.60 divided by 6, and then hit enter. It should give you 2.40 something, 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 something.
So you can't type the whole thing in?
If you try to type the whole thing in,
What you gonna get, Mr. K?
you'll get the same answer. But you're gonna, the calculator gives you this parentheses, right? It gives you that parentheses. You have to give it another one. You have to end it over here, divide by 6, and then hit enter. So the calculator will give you the first parentheses. You have to include another one. Type in the entire top line. After the 7, put in another parentheses, divide by 6, hit equals.
I got like 194.
So,
But that's because you typed it in
You
wrong.
have to type in two.
Do it my way, please.
Alright.
You have to type in 2 from the start.
The calculator gives you the first one. You need to type in the second one. When you hit second square root, it goes square root parentheses. It gives you the first one. You have to include another one.
Cause if you
To
put
say, I want to do the top calculation.
I see. So you take
That's
2
too
from
much.
7. Oh, say it from the start.
Say what from
You see-
Richard?
you can
Do
do
this. Do this. Do this one.
I
Get
put-
the answer to the top, write it down, square root top divided by bottom. You won't make any silly mistakes. Okay. Does anybody see a problem yet? What kind of data were we dealing with on Tuesday? We were dealing with list data and table data. Guess what I haven't talked about yet?
computer data.
Table data. I've done lists here. I've shown you every single element. So what happens if we go into a table?
So that is called list data.
You know, listed, distinct, if you want to think of it that way. But it's definitely not a frequency chart. So if we have a frequency chart, like X, and we have frequency, and we have 2, 5, 7, 9, and 11, and say we have 4, 3, 8, 2, 1 as their frequencies. I have shown you how to find the mean, the median, and the mode of this data, correct? The mean, the median, and the mode. How do I find the standard deviation? Now, if I was going to do the standard deviation with the formula, it gets really, really messy. And you will hate me if I show you how to do it that way. So, here's what we're going to do. We're going to use our calculator. Now, if you have the calculator I suggested that you buy, this is the main reason I suggest you to buy it, so I can show you all how to do this on your calculator. If you do not have the calculator that I suggested you buy, you're out of luck today, and I'll have to help you later. Yours isn't too bad. I don't know how to use yours. Everybody else has my calculator, right? Yeah. And someone's using a cell phone right now. Should I be? Okay. If you're going to use your calculator, one thing you want to type in first is on and clear at the same time. What will happen on your screen, it should say memory reset or something like that. What's it say when you hit on and clear?
Memory clear.
Memory clear. Alright, that just gets you out of every mode that your calculator was ever in, puts it back into factory mode. The second one you're going to hit is you're going to hit the second button. And after you hit the second button, not at the same time, you're going to hit the DATA button. And above DATA, in blue, is STAT. Whenever you hit the second button, you're not hitting the button, you're hitting the blue above the button. Does that make sense? Like square root is the blue above x squared, so you hit second x squared. Now, what happens when you hit second stat?
Some funky stuff came.
You get 1 var and 2 var, right? Hit enter, we're only going to be doing one variable statistics.
Hit enter.
Just hit enter. What happened?
It went blank.
It didn't go blank. Something changed on the screen.
STAT at the end.
There's an STAT at the bottom of your screen. That tells you your calculator is now in statistical mode. Some functions, like I think square root doesn't work anymore. Some of the weird functions on a calculator, the 4 functions will work guaranteed, but some of the other ones get messed up. So if it's in stat mode and you're trying to do calculations, get it out of stat mode first. How do you get it out of stat mode? On and clear at the same time, it jumps you right back to normal. Alright, once you're in stat mode, the next button, the main button you want to hit, is just the data button. Not second data, just plain old data, because guess what we want to enter?
Data.
Or data, depending on how you want to say it. Once you hit the button data, what shows up on your screen?
X1 equals
X1 equals. You're going to put in the first number. The first number here is
2.
2. Hitting the equal sign does absolutely nothing. So the symbol you want to hit is down arrow. Where is down arrow? Top right. Hit down arrow. What's the next thing it says?
FRQ equal 1.
FRQ. What's FRQ represent?
Frequency.
Frequency. What's the frequency of our data value 2? 4.
Right.
You don't have to delete anything. All you have to do is hit 4. It replaces the 1 with a 4. So you type in 4. Guess what you hit next?
Wait a minute.
Nope, enter does nothing.
Down.
Down arrow. So you hit down arrow, that brings you to X2. Do you see what's happening? We're filling in the table as we go with this sequence. X2 is 5. Guess what you hit next?
Down arrow.
Down arrow. And then you get frequency, and you're going to plug in 3, because 5 is a frequency of 3. Finish it.
Down arrow.
Down arrow, down arrow, down arrow.
3.
Just make sure you do not put a data value in frequency or a frequency in data. That'll screw everything up. So make sure every time it's an X, you're putting in an X number. Every time it says FRQ, you're putting in a frequency number. I'll tell you what to do when you get to the end. I know, I don't know how to do yours yet.
Okay.
Wait, this is when that comes in handy. Standard deviation. Underline is under
N
N.
is 18.
N is 18. If you move it over 1,
Six.
what's it represent?
The mean.
The mean, because it says X with a bar on
Oh,
top.
okay.
This is the mean. If you move it over 1 more, what's the underline under?
2.63.
The underline. It's the S, right?
Yeah.
Yes, that's the standard deviation. Move it over 1 more. That's the sigma, right?
The sigma is
Now sigma is
2.5.
your population standard deviation. Notice it's smaller.
2.5.
Yeah, it's smaller than your population. Move over 1 more time. It's off the screen, but move over 1 more time.
108.
EX 108.
It's the sum. The sum of your x's. That first column up here would be the sum of your x's. Move it over 1 more time.
It's squared
The
then.
sum of your x squares.
That's